We tend to think of artificial intelligence as something weightless, a clever piece of code living up in the cloud, generating text and images out of thin air. But the cloud is made of metal, wires, and heat. And when you ask a digital model to solve a problem, a physical server somewhere sparks and overheats. This chart shows global spending on physical data center infrastructure. Last year, tech companies spent $13.6 billion building them. In just the first few months of this year, that number exploded to $49.5 billion. Tech companies are currently in a race for physical territory, buying up acres of real estate to house millions of highly advanced processors. The digital world has an infinite appetite for growth. To run those processors, it has to pull massive amounts of energy from a physical world that has a strictly finite supply of power. AI has evolved beyond a software race. The sheer scale of this infrastructure spending is pulling physical resources toward data centers faster than the global supply chain can adjust. To understand why that infrastructure bill is suddenly so high, look at the cost of a single facility. Last year, a standard data center cost about $177 million to build. Today, that exact same building costs $475 million. This schematic highlights the core engineering problem. A traditional computer processor generates a predictable, manageable amount of heat. A next-generation AI chip runs so fast and calculates so much data simultaneously that it pushes the absolute thermodynamic limits of silicon. Normal industrial air conditioning fails completely against that kind of temperature. The only way to stop these servers from melting is to wrap them in massive, complex liquid cooling systems. Piping specialized fluids directly over thousands of microchips is incredibly complex. That intense heat management is the primary reason individual facility costs have nearly tripled. These facilities function as massive industrial cooling plants, where the energy required to stabilize the temperature often rivals the power used by the servers themselves. When you build hundreds of massive cooling plants at the same time, you create an insatiable, highly concentrated demand for local electricity. Look at this graph tracking global power infrastructure construction. At the start of the year, there is a sharp, sudden spike of 21.2%. We usually associate grid expansion with a transition to green energy, but this massive surge in electrical capacity is being actively bought up by a handful of tech giants to feed their servers. When a data center secures a massive contract to draw hundreds of megawatts from the local grid, that power has to come from somewhere. Traditional manufacturing facilities and residential neighborhoods are left competing for whatever electricity remains. The squeeze extends far beyond electricity. The specialized cooling and manufacturing required for these facilities has triggered aggressive hoarding of critical raw materials, creating sudden shortages in industrial helium and sulfur. The artificial intelligence industry is acting like a gravity well, absorbing the electricity and the foundational chemical components that the rest of the physical economy relies on to function. To understand how severe this resource drain really is, we have to look away from the server farms and look at the dirt. Tech companies are buying up sulfur and industrial chemicals at a premium to build out these facilities. Because those same chemicals are essential to traditional manufacturing, the tech sector is effectively outbidding manufacturers for their own raw materials. This flowchart tracks that disruption. Without a steady supply of base chemicals, the production of agricultural fertilizers rapidly depletes. The economic reality for a farmer is straightforward. When industrial fertilizer becomes scarce on the open market, the baseline cost of growing crops increases. When the tech sector bids up the price of essential chemicals, it creates a new, more expensive baseline for the fertilizers used in global food production. Higher agricultural costs do not stay on the farm. They get passed directly down the supply chain until they hit your wallet at the grocery store checkout. The Macroeconomic Research Office, AMRO, recently updated their forecasts. They project regional inflation will rise by 1.8%, explicitly driven by this new wave of energy and resource depletion. The public is quietly paying the multi-billion-dollar infrastructure bill for the AI revolution every time they buy groceries or pay an electric bill. Faster, more urgent tone. That $49.5 billion was only the spending for the start of 2026. The next generation of superchips is currently sitting in manufacturing queues, waiting to be plugged in. As these cooling plants demand more and more from an already strained system, Will our aging physical grid and supply chains actually survive when the true weight of the AI revolution drops at the end of the year?